A human steps onto Mars alone, no rescue, no backup, no second chance. One small mistake and the mission ends in minutes. Not days, not hours, minutes. Most people think the danger is the cold or the lack of oxygen. That is only the beginning. The real danger is something far more brutal, something most people never think about. Mars looks quiet from space, calm, almost peaceful, but that silence hides a world that actively works against survival at every second. The air is too thin to breathe. The pressure is so low that exposed body fluids can begin to boil. Radiation pours down from space without a shield, and the ground itself is covered in toxic dust that can destroy both machines and lungs. Still, the dream refuses to die. Humans want to go there, to walk on another world, to build a future beyond Earth. Some even believe one person could go alone. A single mission, one astronaut, less cost, less complexity, more control. It sounds efficient, it sounds bold, it sounds like the ultimate test of human strength. But this idea hides a deadly illusion, because surviving Mars is not about bravery, it is not about intelligence, it is not about training, it is about systems. It is about constant maintenance, it is about fragile machines that must work perfectly every second, and here is the truth that changes everything. Those systems were never designed for one person to handle alone. Modern space science, including insights discussed by Brian Greene, reveals a deeper reality. The challenge of Mars is not just distance, it is not just survival, it is complexity stacking on top of complexity until failure becomes unavoidable. On Earth, if something breaks, help is minutes away. On Mars, help is millions of kilometers away. Even communication is delayed. A message can take up to 20 minutes to reach Earth. That means no real-time support, no immediate guidance. Every decision must be made alone. Every mistake must be faced alone. And mistakes are not rare in space. Even the most advanced systems fail, filters clog, seals weaken. Electronics degrade under radiation. On Mars, a tiny crack in a suit or a small failure in oxygen supply does not give a warning. It gives a countdown. There's another layer most people ignore. The human body itself, Mars gravity is only about 1/3 of Earth. That slowly weakens muscles and bones. Radiation damages cells over time. The immune system begins to struggle. Even a small infection can become dangerous. Even a minor injury can become fatal. There are no hospitals on Mars. There are no emergency teams, and then comes the most silent threat of all. The human mind. Isolation on Earth is already difficult. Now stretch that isolation across a dead planet. No voices, no real human contact, only delayed messages. Days turn into weeks. Weeks turn into months. The brain begins to change. Focus weakens. Decision-making slows. Emotions become unstable. In a place where one wrong decision can mean death, that mental decline becomes a direct threat to survival. This is why space agencies do not plan solo missions, not because it is impossible to send one person, but because it is nearly impossible for that person to survive. Every serious Mars mission design includes teams, redundancy, shared responsibility, constant support. Because Mars is not a place where a human survives alone. It is a place where systems fail, bodies weaken, and the mind is pushed beyond its limits. In this video, you will discover the real reasons why a solo mission to Mars is not just dangerous, but almost certainly fatal. You will see how the planet itself attacks the human body, how technology becomes a fragile lifeline, how isolation can destroy even the strongest mind, and why even the best scientists believe that one person alone stands no real chance. By the end, the idea of a lone astronaut on Mars will feel less like a bold mission and more like a slow and inevitable collapse. Welcome to the channel. Subscribe now and step deeper into the most extreme truths of space. Mars looks calm from a distance, a quiet red world under a pale sky, but the moment a human arrives, the truth becomes clear. This is not a colder version of Earth. This is a place where survival is constantly under attack. The air is the first problem. It is not just thin, it is almost not there. The atmospheric pressure on Mars is less than 1% of Earth's. That changes everything. On Earth, pressure keeps the human body stable. It keeps liquids where they belong. On Mars, that protection is gone. If a suit fails, even slightly, the body begins to react in a terrifying way. Fluids inside tissues can start to boil. Not from heat, but from low pressure. Breathing is impossible. The air is mostly carbon dioxide. Oxygen exists only in tiny traces. Without a constant artificial supply, unconsciousness comes fast. Death follows quickly after. Then comes radiation. Mars has no strong magnetic field, no thick atmosphere to block space radiation. Energy from the sun and deep space hits the surface directly. Over time, this radiation damages cells. It breaks DNA. It increases the risk of cancer, but the more immediate danger is less obvious. Radiation slowly weakens the body's ability to repair itself. Cuts heal slower, the immune system struggles, the body becomes fragile in a place. Where strength is already fading, temperature adds another layer of danger. Mars is cold, but the real threat is how unstable it is. Day and night bring extreme changes. Temperatures can rise to a mild level under sunlight, then drop to deadly lows within hours. Metal contracts and expands, materials weaken, seals can crack. Machines that keep a human alive are forced to survive constant stress. And on Mars, when a machine fails, there is no margin for error. Then there is the dust. Fine, sharp, almost like powder. It covers everything. It sticks to surfaces. It clogs joints and filters. This dust is not like Earth dust. It carries toxic chemicals, including compounds that can harm the human body over time. If it enters a habitat or a suit system, it slowly turns into a hidden threat. And when the wind rises, that dust becomes something far worse. Mars can produce massive dust storms. Some grow so large they cover the entire planet. These storms do not last for hours. They can last for weeks, sometimes months. Sunlight disappears behind thick layers of dust. Solar power drops, temperatures shift again, visibility falls close to zero, movement becomes dangerous, even simple tasks turn into risks. A small navigation error can lead to getting lost in a world where every direction looks the same. Mars does not attack in one dramatic moment. It applies pressure from every side, slowly, constantly, air that cannot support life, radiation that breaks the body over time, cold that weakens machines, dust that invades everything. Each factor alone is dangerous. Together, they form a system that pushes survival to the edge every second. And this is only the environment itself. Because surviving Mars is not just about enduring the planet. It is about managing everything that keeps a human alive without failure. Surviving on Mars is not about strength. It is about systems that never stop working. Every breath depends on a machine. Every drop of water depends on a machine. Even warmth depends on a machine. There is no natural support, no air to breathe, no water to drink, no safe temperature. Everything must be created artificially inside a controlled environment. Oxygen does not exist in usable amounts on Mars. It has to be produced. Machines pull carbon dioxide from the thin atmosphere and split it to release oxygen. This process must run constantly. If it slows down, oxygen levels drop. If it stops, survival time becomes very short. Water is another fragile system. There are no flowing rivers or accessible lakes. Water must be recycled again and again. Every drop used for drinking, cleaning, and cooling is collected, filtered, and reused. Even moisture from breath and sweat is captured. The system sounds efficient, but it is also delicate. Filters clog, pipes wear out. Small leaks can grow over time. On Earth, a technician replaces parts. On Mars, one person must do everything. Temperature control is just as critical. Outside, the cold can freeze equipment solid. Inside, systems must keep conditions stable at all times. Heaters, insulation, airflow systems, all working together. If temperature drops too low, electronics can fail. If it rises too high, systems can overheat. These machines do not run forever. They degrade. They require constant checks, repairs, and adjustments. This creates a silent problem. Time, one person only has so many hours in a day. Monitoring oxygen, maintaining water systems, checking temperature controls, inspecting seals and pressure systems. Every system demands attention, and they do not fail one at a time. Failures can overlap. A filter issue appears while a temperature fluctuation begins. At the same time, a pressure seal shows early signs of weakness. Now, the astronaut must decide what to fix first. D, delay one problem and it grows. Focus on another and something else breaks. Fatigue builds quickly, sleep becomes irregular, attention starts to slip, and machines do not forgive mistakes. A loose connection, a missed warning signal, a delayed repair. Each one can start a chain reaction. There is another detail most people miss. Spare parts are limited. Every mission carries only a fixed number of replacements. Once a critical part fails beyond repair, there's no resupply. No shipment arriving from Earth, improvisation becomes the only option, using parts from one system to fix another. This creates new weaknesses. One repair can quietly damage something else. Over time, the entire system becomes less stable. On Earth, teams handle these problems together. Tasks are divided, experts focus on specific systems. On Mars, alone, one person becomes the engineer, the technician, the operator, and the decision maker. Every role, every responsibility, every risk. And the longer the mission continues, the more pressure builds. Because on Mars, survival is not a single task. It is a constant battle to keep a fragile network of systems alive, while knowing that even a small failure at the wrong moment cannot be undone. The human body is built for Earth. Every system inside it expects gravity, protection, and support. Mars takes all of that away, slowly at first, then all at once. Gravity on Mars is only about 1/3 of what the body is used to. At the start, this feels like an advantage. Movement becomes easier, lifting feels light. But the body does not see it as a benefit. Muscles begin to weaken. They no longer carry the same weight, so they start to shrink. Daily exercise can slow this, but it cannot stop it completely. Bones suffer even more. They lose density over time. Calcium slowly drains away. On long missions in space, astronauts already face this problem. On Mars, the process continues without full recovery. A weaker skeleton means higher risk of fractures. A simple fall can become a serious injury. And healing does not work the same way. Radiation plays a silent role in this decline. Without a strong magnetic shield, Mars is constantly exposed to high-energy particles. These particles pass through the body. They damage cells. They break strands of DNA. The effects are not always immediate. Damage builds over time. Cells lose their ability to repair themselves properly. Errors increase. This raises the risk of cancer, but also affects basic body functions. Fatigue grows stronger. Recovery becomes slower. Even sleep can be disrupted as the body struggles to maintain balance. There is another effect that receives less attention. The immune system begins to weaken. Isolation, stress, and radiation all combine to reduce the body's ability to fight infection. Bacteria that would be harmless on Earth can become dangerous. A small cut can turn into a serious problem. A mild infection can spread faster than expected. On Earth, treatment is simple. On Mars, treatment is limited. Medical supplies are restricted. Equipment is basic. There are no doctors nearby, no advanced care. Every diagnosis must be made alone. Every treatment decision carries risk. Even pain becomes a problem. Painkillers can run out. Overuse of medication creates new complications. Then comes the issue of accidents. A slip, a tool dropped in the wrong place, a minor mistake during repair work. These are normal events on Earth. On Mars, they can change everything. A broken bone limits movement. A damaged hand makes repairs difficult. A head injury affects thinking and judgment. Each injury reduces the ability to survive. And there's no way out. Emergency evacuation is not an option. No rescue mission can arrive quickly. The distance between Earth and Mars makes rapid response impossible. Once the mission begins, the astronaut is committed. Every health problem must be faced on that planet. Every injury must be managed with what is already there. The body continues to weaken under constant stress. Muscles lose strength. Bones lose stability. Cells accumulate damage. At the same time, the systems that keep the astronaut alive demand more effort, and as the body slowly breaks down, the ability to manage those systems begins to slip. The human mind is not designed for silence that never ends. On Mars, silence becomes constant. No wind that sounds familiar, no voices nearby, no forces of another human being. Communication with Earth exists, but it is broken by time. Messages travel across millions of kilometers. Each one can take up to 20 minutes to arrive. A question is sent. The answer comes much later. There's no real conversation, no immediate response, no shared moment. This delay changes everything. Simple decisions become heavy. There is no one to confirm a choice, no one to challenge a mistake. Every action carries doubt. At first, the mind tries to adapt. It creates routines. It focuses on tasks. Work becomes a shield against isolation. But over time, cracks begin to form. Days start to blend together. There is no natural rhythm like on Earth. Sunlight feels distant and weak. The sense of time becomes unstable. Hours feel longer. Weeks pass without clear markers. The brain depends on interaction. It needs faces, voices, reactions. Without them, something begins to shift. Thoughts become louder. Small worries grow into larger ones. A minor problem can feel overwhelming. Stress builds quietly. There is no release. On Earth, stress can be shared. On Mars, it stays inside. Loneliness deepens. Studies in isolated environments on Earth show similar patterns. People in remote stations or confined missions begin to experience changes in mood and thinking. Irritability increases. Focus weakens, motivation drops. On Mars, the effect is stronger. There is no exit. No way to step outside into a safe world. Every direction leads to danger. Depression can take hold slowly. Energy fades. Tasks feel heavier. At the same time, anxiety can rise. Every sound from a machine becomes suspicious. Every alert creates tension. Sleep becomes unstable. Some nights feel endless. Other nights pass without real rest. Lack of proper sleep affects the brain further. Memory weakens, reaction time slows, decision-making begins to suffer. This is where the real danger appears. On Mars, survival depends on clear thinking. Every system requires attention. Every repair demands precision. A small error in judgment can have serious consequences. Turning the wrong valve, misreading a signal, delaying a repair by just a few minutes. Under normal conditions, these are small mistakes. Under stress and isolation, they become more likely. Mental fatigue builds day after day. The brain struggles to stay sharp. It loses ability to process complex situations quickly. Even awareness can fade. Important details can be missed. There is another risk that is harder to measure. The mind can begin to distort reality. Long periods of isolation can lead to confusion. Perception can shift. Sounds can feel different. The absence of human interaction changes how the brain interprets the world. This creates uncertainty, and uncertainty leads to hesitation. On Mars, hesitation can be as dangerous as a wrong decision. The mind, once reliable, starts to become unpredictable. And when the person responsible for every system begins to lose clarity, the entire structure of survival begins to weaken at the same time. Distance is not just a number in space. It changes how help works. It changes how decisions are made on Mars. Communication with Earth is never instant. Signals travel at the speed of light, but even that is not fast enough. At the closest point, a message can take several minutes to arrive. At the farthest point, it can take up to 20 minutes one way. At the farthest point, it can take up to 20 minutes one way. That means a full exchange takes much longer, a question is sent, time passes, and the answer returns much later. This delay turns communication into something slow and fragile. On Earth, guidance is immediate. A problem appears and experts respond at once. On Mars, that system breaks. A warning signal appears on a control panel. Something is wrong. The astronaut can report it, but the response will not come in time to help in the moment. The situation must be handled alone. This changes the role of Earth completely. Mission control becomes distant, more like a delayed advisor than an active support system. Every urgent decision must be made without them. Pressure builds in these moments. A system begins to fail. Oxygen levels shift slightly. Temperature control starts to drift. There is no time to wait. The astronaut must act, but acting without full information carries risk. On Earth, teams analyze data from multiple angles. They cross-check, they debate. On Mars, one person must do all of that alone in seconds. A wrong interpretation can lead to the wrong action. And once an action is taken, reversing it is not always possible. There is another layer to this problem. Communication itself can fail. Dust storms can interfere with signals. Equipment can degrade over time. Antennas must remain perfectly aligned and functional. If a communication system weakens, the delay grows worse. Signals can become unstable, messages can be lost. At that point, isolation becomes even deeper. Even delayed support begins to fade. The astronaut becomes truly alone. There is no confirmation that Earth has received a message, no guarantee that help is even aware of a problem. This creates uncertainty. Decisions become heavier. Every action feels final. There is also the issue of timing. Some problems develop slowly, others escalate in seconds. A small pressure drop can turn critical quickly. A system fault can cascade into multiple failures. In these moments, waiting for Earth is not an option. But acting too quickly can also be dangerous. This creates a narrow window A space where the right decision must be made with limited data, under stress, and without support. Mistakes in this environment are not easily corrected. On Earth, errors can be fixed with assistance. Teams step in. Backup systems are activated. On Mars, recovery options are limited. A wrong setting, a delayed reaction, a misjudged repair. Each one can push the system closer to failure. Over time, reliance on Earth becomes less useful. The delay turns guidance into history. Advice arrives after the moment has already passed. The astronaut must rely more on personal judgment, and as pressure builds and systems begin to strain, that judgment becomes the final line between survival and collapse. No serious Mars plan sends one person alone. Every major space agency understands the same rule. Survival on another planet is not an individual task. It is a system built on teamwork. Organizations like NASA design missions with crews, not individuals. This is not just a preference, it is a requirement. Mars missions are built around redundancy. That means backups for critical systems, backup oxygen systems, backup power systems, backup communication lines, but hardware is only part of redundancy. Humans are part of it too. If one person becomes sick, another takes over. If one person makes an error, another can catch it. If one system fails, multiple people can work together to fix it. This reduces risk in a way no machine can replace. Workload is another major factor. Running a Mars habitat is not a simple routine and involves constant monitoring. Maintenance never stops. Data must be checked, systems adjusted, repairs planned. With a team, tasks are divided. Each person focuses on specific responsibilities. One monitors life support, another manages power systems, another handles communication and navigation. This division creates efficiency. Mistakes are less likely when attention is focused. Alone, this balance disappears. One person must switch roles constantly from engineer to medic to operator. This constant switching increases mental strain. It also increases the chance of missing important. There is another reason teams are essential. Problem solving. Complex problems often need multiple perspectives. One person may overlook a detail, another may see the solution immediately. On Earth, even simple missions rely on teams. In space, the need becomes critical. A group can analyze faster, they can test ideas, they can challenge assumptions. Alone, thinking becomes narrow, and under stress, that narrow thinking becomes dangerous. There is also the human side. Psychological support is not optional. It is part of survival.
A crew provides interaction, conversation, shared experience. This keeps the mind stable. It creates a sense of normal life, even in an extreme environment. Without that, isolation grows stronger.
Even trained astronauts are not immune. Long-duration missions on the International Space Station already require careful psychological monitoring, and that environment still has real-time communication with Earth. Mars removes that safety layer. A team acts as a buffer against mental decline. They notice changes in behavior, they support each other, they stabilize the group. One person alone has no such protection. There is no one to notice a mistake before it becomes serious. No one to step in during a moment of weakness. This is why solo missions fall outside acceptable risks. Space agencies calculate risk carefully. Every mission is measured in probabilities. A solo mission pushes those probabilities too far, too many failure points. Too many variables controlled by one person, too many ways for small problems to grow into fatal ones. Even with advanced technology, the margin for survival remains thin. And when that thin margin depends entirely on one individual, the mission shifts from exploration to something much more fragile. Mars is not just far away, it is unforgiving at every level. The surface fights the human body, the environment breaks machines over time, radiation damages cells in silence, silence slowly erodes the mind. None of these dangers act alone, they stack together. They build pressure with every passing day. Survival on Mars is not about courage, it is about balance. Systems working perfectly, people supporting each other, decisions made with clarity and backup. Remove that support and everything changes. A small mistake is no longer small. A delayed repair becomes critical. A moment of doubt turns into a real threat. Alone, there is no second opinion, no shared workload, no one to step in when something goes wrong. The margin for survival becomes razor thin, and over time that margin disappears. This is why the idea of a solo mission fails, not because humans lack strength, but because Mars demands more than one person can give. It demands constant attention. It demands resilience across systems, body and mind. It demands something no individual can sustain alone. Mars will be reached. Humans will stand on its surface, but they will not do it alone. Because in the end, survival on another world is not an individual achievement. It is a shared effort against the planet that never stops pushing back. If this changed how you see Mars missions, take a moment to support the channel. Like the video, subscribe for more deep explorations into space and science. There is always more beneath the surface